All right, hope you're all doing well. Back in my garage today, we're talking about a physical science 1 lab dealing with electric circuits. So we're going to be looking at what's the difference between a parallel circuit and a series circuit, and then what happens when you take multiple bulbs and you put those in a series circuit versus a parallel. We want to be able to measure voltage and we want to be able to measure current. So let me show you the devices we're going to use to make that work today. So the first thing we're going to need in all of these circuits is going to be this power supply. What it's going to allow us to do is just come over here, adjust this knob so that we can change the voltage. And for different circuits, we're going to need different voltage to power these light bulbs depending on how many are in our circuit. We're also going to be using this multimeter. I'm going to show you in just a few minutes each of the different settings we're going to use on this to measure the different values we want, whether it's resistance, current, or voltage. But what we're going to be doing is building these different circuits that you have on your lab handout. And I've got a couple of them put together just to show you, but Z right here is going to be one we're dealing with. This is a series circuit, but it looks something like this. I'm going to try to label them as we're going through here, so when you're watching you can tell clearly which one we're talking about. Okay, but we're going to have a setup here with this board with up to 3 different little light bulbs here. They're going to be connected in different ways. Now these wires, doesn't matter what color they are. I'm just using different colors so you can see my connections easier. Okay, but each of these wires are called banana plugs. They're just useful for plugging in open ports like this one right here. And they're also useful for being able to plug them in to one another to make connections right there as well. All right, but this first one, Z, okay, let me go ahead and define what we're talking about. This is a series circuit. What makes this as a series circuit is if I start over here at the power supply and I start going through this diagram, I know it's a series circuit because there's only one pathway that's going to take me back to the power supply. Now down here on the bottom, when we get to these circuits, these are called parallel circuits. And this is M that I've already put together for you right here. And so what you see is there's no connection from, from say the left side to the right side using the wires. But here's our diagram. And what makes this a parallel circuit is when I start at the power supply, I've got multiple options in order to start at the power supply and for the current to be able to return to the power supply. So in fact, in circuit M, we've got 3 options. Current can travel through one bulb or the other 2, but have 3 different pathways. That's going to make this a parallel circuit. Our multimeter over here, we call it a multimeter because we can use it to measure multiple quantities. We're going to use it to measure resistance, voltage, and current. That's got a couple of leads, a couple of wires coming off here. They have little alligator clips attached to them so they can grab onto things. But I can just as easily pop that off and use a banana plug right here on the other end as well. All right, but to measure some of our quantities, first thing we're going to be measuring here in just a second is talking about resistance. Resistance is measuring how easily or how difficult it is for the current to flow through, and we want to be right over here with this little omega symbol. That's the Greek letter omega. That's the unit that's a symbol we use to measure ohms. Ohms is the unit for resistance. So you're going to see me turning the dial over here to measure the resistance on these light bulbs. We're going to have it set over here to measure up to a maximum of 400 ohms when we do resistance in just a moment. When we get ready to measure voltage, we're going to turn it back up here to about 1 o'clock on the dial, where you can see the V right here for voltage, and that's going to let us measure voltages up to about 4. Now when I get ready to do current, one thing I'm going to do is I'm going to take this connection on the bottom and I'm going to switch it over to the other side right here, as well as take my dial and turn it up here to 10 amps. So all of those changes and those turning of the dial. I'll be doing all of that as we're going through here measuring these different things in just a moment. First thing you're asked to do in this experiment is come over here, take each of these bulbs, measure their resistance. So I went ahead and labeled them over here 1, 2, and 3. I've got my multimeter set up to measure resistance. I'm going to take just each of these leads. I'm going to measure light bulb number 1. Now the important thing to notice is I'm measuring resistance. I don't have these light bulbs connected to anything else. I don't want them to be turned on while I measure their resistance. So for light bulb number 1, we're measuring 1.2, maybe 1.3, 1.2. We'll go with 1.2 ohms right here. Okay, so light bulb number 1, 1.2 ohms. All right, I'm going to take my connections, I'm going to move them over here to number 2, and this number is going to bounce around for just a minute, but it'll settle out here. Now I tried to use 3 slightly different light bulbs, so we should get 3 slightly different resistances here, but they're going to be close. So we'll call it 1.6 ohms, even though it's still bouncing around. Okay, so light bulb number 2, 1.6 ohms of resistance. And then one more, let me measure number 3 over here. All right, the same way, bouncing around a little bit. We'll call that one 1.0 ohms. Okay, so almost forgot my ohm symbol right there, so make sure 1.0 ohms for number 3. We're constructing circuit X right here. We want one light bulb, we want 2.2 volts on our power supply. So come over here to our power supply. I got it set on 2.2. I'm going to go ahead and turn this on right here. And then for my circuit, I've got my connections from my power supply coming over here to just one single light bulb for circuit X. And the first thing we want to do over here is we want to measure the voltage. What is the voltage across this light bulb? So I'm going to take my multimeter right here. I'm going to take my connection. I'm going to plug it in here to one side. I'm going to take the other, plug it in to the other side, and look at the voltage we're receiving here. Okay, we'll call it 2.37 volts. Even though, again, it's going to want to bounce around just a little bit, but that's not unusual. 2.37 volts. Okay, now we need to measure the current. Okay, so here's what's got to happen. I'm going to unplug this. All right, so unplugged it. I'm going to turn my dial over here to current. I'm going to switch my connection like we talked about earlier. All right, here's the key. Here's where students in lab get mixed up all the time. To measure current, what I'm going to do is I'm going to pop one of these connections, and that's going to turn off my light bulb. Now what I want to do is take my wires from my multimeter, plug one in where I just disconnected everything. I want to take the other one and I want to connect it to the wire that I disconnected here, and trying to do this one-handed while holding the camera in the other hand. On the rest of them I'm going to kind of skip over this because I'm just showing it to you now. Okay, but all right, so here's what happened. When I made that connection, my light bulb turns back on. That tells me now there's current still flowing through here, and that current's flowing through this multimeter. So now we're measuring current 0.258 amps. That little A in the corner is standing for amperes or amps. So 0.258 amps. I still have a series circuit, but now 2 light bulbs connected to our power supply and 5 volts. So I'm going to come over here, I'm going to change my dial up to 5 volts. Go ahead and turn this on right here. Okay, and looking at our two bulbs. Now what you notice, one of these bulbs is much brighter than the other one over here. Okay, but I know this is a series circuit. I got my current coming in one side, going across the bulb, flowing through the wire, back to the next one, back to the power supply. So let's get these voltages. Let's start with this first bulb. Okay, I'm going to measure its voltage, plug it in each side right here. All right, we're getting a voltage 3.40 volts. So let me come over here, get to the correct page. All right, so on circuit Y, 3.40 volts. All right, and then let's check our second bulb. All right, pause there while I switch those connections. So now we're connected to our bulb number 2, looking at our voltage right here. 1 point, it's on its way down there. We'll call that 1.73 volts. All right, 1.73 volts. Okay, so notice right here, we got two different voltages. The higher voltage corresponds over here to the brighter light bulb. Okay, but here's what you want to notice. If you take these two and you add these together, okay, now that's going to add up to like 5.13. But adding those two together, very close to our 5 volts right here. When we had just one bulb, notice we were getting 2.37. Pretty close to what we had our power supply set on. We could safely say our power supply over here is probably putting out a little bit greater voltage than what the knob is labeled for. All right, so let me show you the current. All right, so I had a bone bulb. It wasn't even the one I expected. I expected that I probably would have blown out number 1 with its greater voltage, but blew out number 2. So I've replaced that. We're back ready to measure these currents right here. So I'm going to break this connection again. I plug in here, take my 2 wires, plug those together. Let me get them good and tight. All right, so we're measuring the current flowing in to bulb number 1, and we're getting 0.335 amps. Okay, so for bulb number 1, 0.335 amps. All right, let me get number 2 set up. All right, so I replaced our connection here. Now notice I've broken the connection on the other side, made that connection to my multimeter. The other end we're going to plug in. Everything turns back on. We're looking at the current again now. 0.33, see if it's going to stop, 337 amps. Okay, 0.337 amps. All right, so here's what we're going to talk about with these currents. Notice these two are basically the same thing, and that should happen in all series circuits. They should have the same current flowing through each bulb because there's only one pathway for the bulb to flow through. All right, let me get Z set up for us. Constructed circuit Z. So now again, we're looking at 3 bulbs all in a series circuit on 7.2 volts. So I got it set up here, 7.2 volts. We got all 3 bulbs going, all of them lighting up. So let's come over here, let's measure the voltage for the first one. So make my connections here from one side to the other. Measuring this voltage, 2.97 volts for the first bulb. Right. Sorry, my shadow's getting on my paper there. 2.97 volts for number 1. All right, let me get number 2 ready. All right, so moved my first connection over to number 2, making my second connection right here. Number 2, we're getting a voltage 1.55 volts. All right, so number 2, 1.55 volts. All right, and let me get number 3. All right, so one connection made on number 3. I'm plugging in the other side right here. And number 3, now we're getting a voltage 2.75 2.91 volts, right? So 2.91 volts. Now you may have noticed my red and black, I flip-flopped them each time. If you switch these connections, if you put the black here and the red here, all that's going to do is give you a negative voltage over here. And that's just because the current's going the other way through the multimeter if that happens. All right, but let's talk about one thing here real quick. For this circuit Z, what's going to happen if one of these light bulbs were to burn out? If one of these bulbs were to be unscrewed or get loose right here, okay, notice that makes the other ones turn out. Maybe that looks like, some Christmas lights. If this one gets a little loose and wobbly, you bump it a little bit, they might turn on, but it gets bumped again, okay, and everything might turn off. But that's what happens in a series circuit. Because there's only one pathway for the current, everything will go off if one of them goes off. Ready to measure current on circuit Z. I made our first connection to the multimeter after I disconnected it from the light bulbs, making this plug-in, everything turns on. All right, and our very first current, we'll call that 0.317 amps. All right, so 0.317 amps. Let me get number 2 set up. Alright, measuring current number 2 on Z. Got my disconnection made here. Plug this back in. Everything lights up. Current 0.317. 6. We'll call it 6. It moved right there at the end. Alright, last current here on Z. Broke our connection. Reconnecting, everything turns on. Current 0.317 amps over here. Okay, and again, this is what I was talking about earlier. Notice these currents basically identical here on this series circuit because there's only one path for that circuit. And there's questions down here. We just addressed this just a minute ago, so go back and look at that if you need to. We talked about these currents a minute ago. All right, so let's look at these. This is basically 3 volts, 1.5, just about 3 volts here. Again, you add these up, it's going to be really close to this total voltage, the voltage of the power supply. So basically these bulbs, they're sharing those 7.2 volts, and they don't share them equally because they didn't have equal resistances in the first place. 2 bulbs again, but now we want them connected in parallel. Again, key is parallel. We got 2 different pathways to leave this power supply and return to it. Okay, set on 2.2 volts. Notice all of these, they're all going to be on 2.2 volts for these parallel circuits. All right, so we got that set up here with our voltage adjusted. We need to measure the voltage for each bulb here. So I'm making my connections here for bulb number 1. And we have a voltage 2.299. We'll call that just 2.30. We'll just round it up here like we've been doing on the other ones. 2.30 volts. Let me get number 2 set up. Alright, so switching my connections over here to light bulb number 2. And now we're getting the voltage 2.26 volts. Alright, 2.26 volts. So this is going to look just a little bit different measuring current for this parallel circuit. I'm going to pop the connection here. Notice only bulb number 1 turned off. Number 2 stayed on. That didn't happen when we were measuring current on the series circuits. So now as I take my multimeter connections and reattach to fill up that gap that I just created here. All right, so as I plug in my wires, bulb number 1 turns back on. We're looking at the current flowing through it, 0.277 amps. 0.277 amps. Let me get number 2 ready. Alright, so I broke our connection right here next to bulb number 2. It turned off. Went ahead and reconnected here. Make our final connection. Bulb number 2 turns back on. Now we get a current 0.377 amps. Okay, 0.377 amps. All right, so why does this happen? Why do now we have a larger current? That's because, if you remember, go back to the beginning, bulb number 2 has a smaller resistance, so now it's going to get a little more current flowing through it than bulb number 1 that had a higher resistance. Higher resistance is going to have less current flowing through it when things are in parallel. Even though the voltages up here are pretty much identical, okay? Parallel circuit, identical voltages, not so on the current. Less resistance, greater current. 3 bulbs in parallel, 2.2 volts. So all set up right here, 2.2 volts on the dial, ready to measure these voltages. So as we start to make our connections for bulb number 1, okay, you notice that negative? That's just me plugging in the wrong side right there. That's fine, ignore that. Okay, 2.21 volts. Right. Other thing you didn't see a minute ago is I just forgot to turn this dial just a moment ago. Forgot to take it off of current and switch it over to voltage. That's why I had to scratch out a number just a moment ago. All right, so let me get set up for number 2. All right, making our connection on bulb number 2. Got one side already done. So now I got them on the right side. 2.16 volts. 2.16 volts. And then let me get number 3. All right, last one here measuring the voltage. Bulb number 3 on circuit M. 2.10 volts. All right, 2.10. All right, so these voltages again, parallel circuit, they're all virtually the same. Now the reason number 3 over here is a little smaller than number 1 is because of all these extra wires. Okay, all that current's got to run through these extra wires before it ever makes it to bulb number 3. That's going to cause a little bit of voltage to be lost in each of these wires. So number 1 seems to be getting a little more voltage. Ideally, they would all be equal voltages. All right, so measuring current on circuit and went ahead, broke my connection, connected that to my power supply, or sorry, to my multimeter, ready to plug that in right here and to record a current of 0.273 amps. 0.273 amps, and we'll get ready for number 2. All right, it's the same type of thing. Broke the connection next to bulb number 2, reconnected that to my multimeter, plugging in our other side here. Bulb number 2 turns back on. Now we've got 0.372 amps. 0.372 amps, and then one more to go. All right, one last measurement. Disconnected, reconnected, bulb number 3 turns on. 0.272 amps. All right, so bear with me just a minute. Got a couple of things here to show you regarding these questions. The first one being that what happens if one of these bulbs goes off and they're in parallel. You might have already figured this out based off measuring the current, but if one bulb turns off, the other ones continue to stay on. So this is like most of the wiring in your house. One bulb in the living room goes off, the other ones stay on. Okay, one of the headlights on your car burns out, the other one stays on. Or the good Christmas lights that you want, one bulb goes out, the rest of them stay on. All right. Right here looks an awful lot like L using 2 bulbs, but we're going to have one extra wire in here. We want to see the difference this makes. So right now, this is basically just like L. Got the 2 bulbs in parallel. I'm going to take this one extra wire, and notice when I plug it into the other side, everything just turned off right there. But when I take it back out, if I can do this one-handed, and when I take that out, everything turns back on. So what's going on? We got this one extra wire and everything turns off. So what we're doing here when we make this extra connection is we're creating a short circuit. Let me show you over here. Current is basically lazy. It likes the path of least resistance. So this current has options. The current can pass through the first bulb back to the power supply. That's one pathway. The current could pass through the second light bulb back here to the power supply. That's the second pathway, and that's exactly what's happening in circuit L. It only has those two pathways to choose from. But now we've created a third pathway. And this third pathway is just a wire. And because there's just a wire here, there's basically very, very little resistance. And so all of that current's going to go this way where there's no resistance back to the power supply. And so none of the current is flowing through the other two bulbs. That's why you see them turn off. There is minuscule current flowing through them, but not enough to make them light up. But that's what's happening. You're creating a short circuit when you're using this circuit in right here. This is bad news in your house because things start to overheat. This wire right here will get really hot, possibly cause an electrical fire. All right, so hope all that kind of made a little sense to you about how to measure resistance and voltage and current, what's the difference between a series and a parallel circuit, and how those voltages and currents change inside of those. So key takeaway here was when you have a parallel circuit, everything should have an equal voltage. When you have a series circuit, everything should have an equal current flowing through it because there's only one pathway for that current to flow. As always, if you need any help, feel free to reach out to me. I'm here for you.